Hello, welcome back. This is Jeff Byers, and this is NE255, and this is Module 7. We're going to create a milk simulation. I'm going to have you guys model a pitcher, a glass pitcher, and then a drinking glass, and you're going to pour the nParticles into the glass and make it as close to a liquid simulation as we can make it. So we're going to step it up now. We're moving from traditional particle system in Maya to nParticles. Okay, so this natural progression. Now you kind of know how things work, and so what we're going to do is we're going to up the game with these nParticles, which include a nucleus now that allow us to do a lot more things. They can self-collide with each other. And so these attributes can really come into play into making things look more realistic. So now we're going to go ahead and get started. You're going to find this video, of course, you're watching it right now, but under Module 7, Lesson Content, Lectures, and Video Tutorials. And we need to talk about nParticles, okay? nParticles is a particle generation system that uses Maya Nucleus. So that's a dynamic simulation that works with also with these other N. You can see anything in here. nParticles. We've got nCloth, nHair, nConstraints, nCache, and so on and so forth. So these all work together. Whenever you see this, now fluids is something different, okay? But these will work together, okay? So just keep that in mind. And again, we have our fields and solvers in here. We've already kind of covered that a little bit. We'll get more into that in depth in our other modules. So, nParticles. So what are we going to do? We're going to create a liquid simulation. We're going to start off slow, though. So I want you to download this scene, okay? So go ahead and download the zip folder, unzip it, copy and paste the contents into your scenes folder, and hopefully you created a scenes folder that basically says NE255 module 7 milk, and you can then place this file in there. It's just an MB file. Okay, so that file you should see in your right here, so it's in that zip folder. And it's the nParticle liquids example start 1. That's what we need to put in. And go ahead and go to File. Once you put that in, go to File, Set, and then set your project. And then you can go to File, Open Scene, and you should see this. Okay? Alright, so just very simple scene, but that's the way we want it when we start just learning how to do things. Okay, so again, you need to make sure that you read Module 7. I take you through what are nParticles, what you can do with nParticles, and how you emit particles. We'll take you through that right now. So we're going to go to nParticles, and as you know, we were using legacy particles. We've moved on from these, and now we're going to go into the nParticles. So let me take you through the options. So we have point, balls, cloud, thick cloud. We're going to use water, so make sure you click on that one. Make sure it's highlighted. Okay, all right. And then, like anything else, we can click on nParticles, and we can do fill object, which we'll do with the pitcher. Okay, but right now we're going to take you through how to create an emitter and use that. Okay, you can also emit from object like you could before, from a surface or from a NURB surface, a object like geometry, polygons, and you can also use a curve, but you can't see it, but you can use it, meaning it won't render. Okay, so let's go ahead and click on Create Emitter and go into the option box. Create some from solver. We're going to use, this usually comes in as Omni, we're going to use a volume, and we want to use a sphere. This comes in as a cube, but let's go ahead and use a sphere. And click on Create. Alright, so the emitter creates a particle solution and a nucleus solution. Okay, so let's take you through, let's click on the emitter, let's hit the W key and move that up so we can see it. Okay, that looks familiar, doesn't it? It looks just like the the regular particle system, the classic system that we were using before. So I'm going to pull that back a little bit like that and get it to the end here, okay, so we can see it kind of spilling over. And so if we go ahead and play the solution, now remember we're using particle simulation, and you need to make sure you set your settings up to play every frame and playback max playback speed at 24 frames times 1. Make sure that's all set up. Click on save. If you don't save it, it won't work. It will just resort back to where it was. And you can see my timeline set up to 500. So go ahead and set that up. Just highlight it and click 500 in it. We may need more. I don't know. We'll have to see. Okay, so let's go ahead and play. Now you notice that it just falls through. And what's different about this is that we can't click on Make Collide in the particle system anymore, because we've moved on from legacy particles into something a lot more complex. So before we had to go in to select the object, and then we need to create collisions, say like Make Collide, but that won't work with these. Okay, so that's one of the things you need to understand. So I'm going to move that up again. Let's go back to the start of the simulation. So let's talk about what we are getting with this. It's a lot more complex. So that's the reason why we start with the classic, the older particle system, kind of get you used to it. Now you know how to use it. Now this will seem a lot easier. Just a couple things to remember. Alright, so in the nucleus, what is that? That basically gives us all of this stuff, which is gravity. So it automatically adds gravity to it, which is great. Okay, so you can see that nParticles, let's say you don't want gravity in your scene, then nParticles won't work for you. So there are some reasons why they keep the classic particles in there, because you may not want the gravity for a certain situation. So this will include it. Whether you use it or not, I mean, that's easy to switch off, right? So let's go ahead and bring that back up. Alright. We also have the direction. This all looks the same, except for the fact that we have air density too as well. Okay? So air density is at 1. That's the air density we have. Now if you have thicker air or thicker atmosphere, you would go up. If you want thinner atmosphere, you would go lower. And then the wind speed would be how fast or how forceful the wind is. The wind direction is basically X, Y, and Z. And wind noise is a randomizer that basically adds noise to the wind. Okay, so if you were going to do a cloud and you want it to be wavy or whatever, you could put that in there. Okay. All right. Solving attributes. If you find that the solver isn't solving properly, or you can step up the iterations. So substeps basically allows you to go ahead and make the simulation a lot more higher resolution. So it's going to slow you way down though, so be careful. I usually keep it like that. Unless you run into issues, you can turn that up. Max collision iterations at 4. The higher you go, the more sensitive to that collision it will be. And at 4, I would just keep it at that. Again, if you raise it, it will slow you down. If you lower it too much, you get a bad collision. Okay. Alright, we'll keep the collision layer range the same, and the timing, we're not going to mess with any of that stuff. So this is what you see in your nucleus, okay? So you can make changes in there, so just kind of keep that in mind. And then in nParticles, holy smokes, look at the stuff we have in here, okay? This is a lot more complex than what we're used to seeing, okay? So I can open all that up, and I can't even get it all the way open. So in particle shape, that's our particles, basically what they look like, how you can control them. But this has a lot more stuff. So what we want to do is we just kind of want to focus on a couple things, and that is the lifespan. Okay, we talked about this. Now, when we're creating a liquid simulation, we don't want the particles to die off. That would look really weird. Okay. And with the particle simulations before, it worked really good being able to kill them off. Now if you do have to kill them off, then you can go in here and change it to constant or random range. So you know how to do that already. So that looks familiar. Okay. The next thing is collision. Now the particle size, that's where this is. Okay. Before, in the classic, they were under what the particle looks like. Okay. The style. Well, we really don't have a choice here because we clicked on water. So now we don't have, the points and the multi-streak and the streak. That all went away. All right. So you're not going to be able to do those really cool, and I think those fit into stylistic animations. You may disagree with me, but not all that. You're not going to be wanting photorealistic simulation. And in fact, when I see stylistic stuff, I kind of expect it not to look photoreal. So it looks a little strange when something looks stylistic and you're throwing in real water. But everybody does it. So whatever works for you. But all I'm saying is that sometimes those streaks and multi-streaks and those kinds of things are a lot of fun to play with, and you could probably use them sometime down the road. Anyway, don't forget about them. So the radius, that's just the size of the particle. Okay, obviously when I go in here and I want to change the size of the particle, I can go in here and make it twice as small. And so you can see we get that. But right now we want to keep it pretty big so you guys can see what's going on with this demonstration. Okay, so let's go back. There we go. Alright, cool. Alright, so scale radius we're not going to work with, we're not going to play with too much, we'll work with it later, but let's just go through very quickly the collisions. Now this is something that you wouldn't see, and there's a lot more things in here that are a lot more intricate and sensitive. So what's cool about this though, that we weren't getting from the classic particle system, is that they self-collide. So you have these spheres now, and they will actually collide with each other instead of going into each other. Okay, which is really helpful. Okay, now when we clicked on water though, water molecules or water balls of water will collide with each other. Not collide like gumballs, but they'll collide and they'll absorb each other. Okay, make one mass. So we have to turn that off, but we'll look at this and turn that back on in just a little bit. All right, so another thing that you need to make sure you understand is that when we look at collide strength, it's kind of like when we looked at the nucleus, that basically collide strength, we keep at 1, and if you want to bring it up a little bit higher, it will slow you down a little bit. But usually we just keep it at defaulted at 1 or lower. Okay, collision layer, collide with scale, collide with the scale itself, and then there's that solver collision thickness that allows us to see the collision thickness and make changes to it. It actually shows it. I don't have it on right now. But when I play the animation, you can see that that's the collision thickness. Okay, so when you make changes here, you can see some of the changes that happen through here. Be very careful. Keep it at the default unless you need to change it. Unless particles are flying through objects and you need to change the solver display or solver thickness or the collision thickness. Okay. Let's turn that off a minute. There we go. So I didn't change anything here. And then we have what looks really very familiar. But they actually call it what it is, which I think is more interesting. Is interesting because before I think it was called resilience or something like that in the classic. So now it's bounce. So it is what it says. You can give it bounce. Now everything has a bounce. You should never have anything that's a 0, even if it's a bowling ball or a solid piece of steel hitting a piece of cement. It's going to bounce depending on what it's hitting, especially if it's hitting another steel ball. It's going to bounce like crazy. But it may not bounce that much if it's hitting cement and smashing it. So you might sometimes use 0 if that's happening. But usually a drop of water or something like something very small, 0.1 or 0.01 or something like that. You can play with that a little bit. We'll keep it at 0 right now. And friction, You know what that is. So the water sliding across an object, it's going to slow it down. Okay, that's the friction. The stickiness is literally that you can have two pieces stick together, or if you have a sticky piece of tape and trying to roll something over it, it will slow it down. Okay, so that's new. We didn't have that before. That's really cool to play with. And then the self-collide iterations, again, this comes with the same thing with the nucleus, which is nice to have these separate. That if you see that the particle simulation is going through something, you can bring it up. Or you see the particles hitting each other and going into each other, you can turn that up or lessen that. Don't go too crazy. Don't go in there and go, okay, I'm going to type in 10, and you could crash your system. So just go up one at a time until you find the best solution. Okay. Right, that's collisions. And then dynamic properties is another one that's very important. So we've got forces in the world. We could turn that off anytime we want to, and if we do that, and we could click on ignore gravity, that means it will just ignore it, and it basically ignores everything in the scene. So if you have wind and stuff in there, and you really get confused of what's going on and what's happening, it's nice to be able to turn some of these things off to find out if it's actually working. So you can turn off forces in the world, which could be like a turbulence field. Ignore solver wind, which is the wind. You can ignore that, and you can ignore the gravity. Okay, so that's kind of nice. Alright, so we want to keep those off. We got local force, local wind, dynamics weight. That's the actual weight of an object, how heavy it is. Okay, and then we've got conserve, and we've got drag, and we've got dampening. Okay, these things we're going to play with a little bit so you guys can see what's going on in here with the conserve. And we'll talk about that. Alright, so let's go ahead and let's get started. I think I have one last thing I want to talk about. Oh yeah, liquid simulation. So let's go down to liquid simulation. So those are the ones we're really looking at, and you can see this is pretty intricate here. So liquid simulation, now enable liquid simulation. So we need to have that in there. That needs to be on. Okay. Incompressibility. Now we're going to talk about that as we go through these, so you guys can see what's happening. But we're going to talk about these three things. Viscosity is very important, and then we've got viscosity, and surface tension is really important in liquid. Okay. Now viscosity is how thin or how thick. Basically water or syrup or sap or glue. That's viscosity. Okay, how thick or thin the liquid is. And surface tension is basically a surface tension, depending on the type of fluid it is, will allow really small teeny little bugs to actually float. They won't drown or anything, they just float on top. And I'm sure you've seen those little bugs that float around on top of the water. That's because of surface tension and their body weight. They're able to float right on top of that surface tension, the surface of the water, and that's basically the tension before something like two pieces of water droplets hit, and how they absorb each other, how they stick to each other. Okay, and surface tension causes puddling with fluids. Okay, all right. So anyway, that is that, and we'll look at this a little bit later, but we'll keep that open. So those are the four things I want you to have open. So liquid simulation, and dynamic properties, and collisions. Okay, all right. So that works out. That way you can kind of get an idea how we're going to do this. Okay. So let's kind of look at what we have, the only way to look at it is to, let's pull it up a little bit higher. Okay. And we're going to go back to all the way to frame 1. And we're going to go ahead and select the particle. Actually, I don't even think we have to do that. I think the nNucleus will work with anything. So we're going to go ahead and select the object. And, whoops, and hold down the spacebar. Make sure you have just your show effects and effects only. And go to nParticles, nCloth. And create passive collider. Okay, so now the particle should now interact with these without actually even having to select the particles and shift select the object. I keep forgetting that because I'm so used to using the classic particles. So again, I'll show you how to do that again. So what you want to do is just click on the object that you want the nParticles to collide with, and hold the spacebar and go to nCloth and create passive collider. Okay, and then you do that same thing with this object. And I wouldn't do a bunch of objects at once. You may get away with that a couple of times, but you also may cause Maya to crash or to cause errors in your simulations, or just corrupt the file, and that's not good. So always save your work every 5 minutes. I haven't done that, and I don't usually save my work when I'm demonstrating, so I can get through it quickly. So, but I just want to remind you to save your work as you go along, and you can always pause the video to do that. Alright, so let's go ahead and select this guy and go to nCloth and do the same thing, because I want those to fall off. Okay, so that's what they're going to do. They're going to fall off. And I put it back on this little object here as a backsplash. So these are just going to go and go and go and roll off, and I don't want that to happen. So let's take the first step in how do you want this to simulate. Okay, that's the first thing we want to do. We want it to look like water, so we need to start thinking about how this will actually look. So what I'm going to do in this simulation here is just we want those little water particles to stop when it hits here and pull up. And so what I need to do is go into the cube and the object, and let's go in here to friction and stickiness, and we can turn that up. So let's do, it's at 0.1, so it's going to roll around. So let's just do 0.7. Okay, and let's take a look. I don't think I have to put on stickiness. Let's see what happens. And yes, they just just kind of stop and stay put, and they'll pool right there, which is kind of cool. Okay, so if you want them to roll a little bit, you know, they're going to push each other. See how they're pushing out, which is really cool. Okay, all right, now let's take a look at this and let's talk about the particle system. And let's go to self collide. Now I'm going to show you this. Now these will look like gumballs now. So when I play the simulation, now they're going to see, yeah, so when they hit each other, they're being pushed around a little bit harder, which is really cool to see, because we're not able to get this in with the classic particles. So you can see that it's literally they're building onto each other and creating a mass right here, which is so cool. So if we gave it long enough, it would just fill the whole scene, as long as your computer could handle simulating these. Okay, so that's pretty cool. Actually, it's really neat how that works. Okay, let's go ahead and stop and go forward. So with that said, we don't want that to happen, because we want liquid to work. In fact, I need to go and make sure the enable liquid simulation is on, so we need to make sure that's set up. Okay, so let's take a look at some of these other things that we have. So with our particle simulation, we do have the bounciness, the friction, and the stickiness. So we want it to look like water, so they're not self-colliding anymore. Okay, so that's good. That's a good thing. Okay, so let's look at the other things we have here. The mass of each one of these objects is good. Okay, max input. enable liquid simulation, viscosity, and all this other stuff we're going to have to play with a little bit. Let me look at some other stuff. Conserve, and let's look at that. So conserve. Alright, so let's take a look at that one. And if I turn that all the way up, or excuse me, all the way down, they're just going to be super thick. Okay? So that helps you with the thickness. So I'm going to go about 0.5. Gives you almost like you're shooting some foam out. Okay? And look how slow it is. There we go. Pretty cool. Let's go back in here. And let's make a look at a little bit. There we go. Okay, that could be like soap coming out. Suds coming out of a washer. And the same thing with drag. It's basically the same exact thing. Drag's going to hold them together as long as it can. So drag works really well. So even a small amount, it's going to slow it down. Okay, so keep that in mind. So that puts a drag on, and then dampening is same kind of thing. Let's go ahead and go in here. They're going to hold them. It's going to hold them as long as it can. And what's cool about this, what I love to do is I'm going to now push it all the way back to 0. Watch what happens. Oh, it didn't work. Usually it pulls on it. Let me do it with conserve. Let me try that with conserve. See, like all the way up, so it just kind of whoops, that's not it. That's not what I want to do. Let's go all the way conserve here like that. Okay, let's go back. There we go. Okay, here we go. I'm just going to kind of plop it, and I'm going to pull this forward and just drop it. That's always fun to do. I'm sorry, I had to do that. So you can animate that to do that. You can have it clump and then have a drop. You know, you could have like a real close up view of a water dropule, and you can have that conserve up, and then you can animate it to release. You know, release to drop. That's pretty cool. Anyway, you can do something like that. So let's go in here, make sure everything is. Where did I have on these? Now I don't remember what this was. So conserve was like that. There we go. So we're back to normal here. Okay, great. Alright, so right now we went through these guys, okay? And what we're going to do is go into the liquid simulation and take you through that. Incompressibility. That's a good mouthful there. Say that 3 times in a row. Will cause your particles to stick together more, or cause them to stick or not to stick at all. So let's go ahead and put that on. So 0 is just clump and stick together. So right now we can just put it to 0. Is that 1? So when we do that, they're going to clump and stick together. Okay. So that's kind of interesting. So I suppose that would be like snow. They're not really building onto each other either. They're just kind of stuck. That's not fun. All right. It's really not building up to anything either. So that's kind of. So we're going to put that at back up to 1. Okay. Now let's go back here. And you can see that if we go up to, what do we have it at 1? If we go above that to something like 5, okay, always hit enter, and we play it. Now they're just going to try to keep away from each other. So really where it was set at 1 is probably where you're going to keep it. And if you vary it, it's going to be just little small amounts like 1.1, 1.2, or 0.9 or 0.8. Now the rest density is how far particles can interpenetrate each other. At 4, they will push into each other. So basically, you can control how far they interpenetrate each other. So right now the rest density is at 2, but if we set it at 4, you can see that they can get a lot closer together, and that causes it to pool a little bit more. Okay, they're still building on top of each other, which is kind of cool. It's almost pooling like water, isn't it? Look at how that's working. Very cool. All right, so we can use that to our advantage then with this water simulation. All right, so let's pull that back. What do we have it at? 2. Okay. All right, so 2. Liquid radius scale. What does that do? Basically, where the radius collision occurs at 0.5, the collision of each particle is half, and they will self-penetrate each other halfway. So, liquid radius scale. Let's do 0.5. Okay, so 0.5. Alright, so let's go ahead and take a look at that. And so they are penetrating themselves a lot farther than they would have, so if you need that, you can see that they're not pooling as well. I don't really like that as well, but it's working. It takes a lot more. They're pooling and they're pushing out, but it takes a lot longer because you have that liquid radius scale too low. Okay, so let's keep it at 1. And we may need to have that, use that when we're actually simulating the water, but right now we're just going to go ahead and keep it at 1. Alright, viscosity. Again, we just talked about that, how thin. And we could set it to something like 10. Okay, viscosity at 10. Alright. It's going to give us a thicker simulation. A lot goopier, globbier, and you can see that it is building up on itself a little bit more. Okay, so that works. What did I have that at 0.1 or something like that? Alright, so there we go. Bring that back again. Alright, so and then we have my favorite one, which is the surface tension. Okay, and this is whether they stick together or not. So let's go ahead and do surface tension of 1, and we may not see a huge difference in this. Let's go ahead and play it anyway. Okay, so there, you can see them pooling a little bit. Let's go a lot more with that. Let's go something like 10. Let's go pretty up a little bit higher and play. There we go. So that's insane. Look at that. That's kind of a cool simulation. And they're popping over. They're popping around like popcorn. All right. So that's not working. So let's keep it at 0 right now. That was pretty cool though. And let's go ahead and play the simulation. And then basically I basically took you through everything that I wanted to for this particular video. And I think in the next video we're just going to get serious about getting it to look like water, and see if we can get it as close to water as we possibly can, and maybe even see if we can do a fast render. And we're actually going to be able to use Arnold with this. Some of you have V-Ray, and I'm okay with that if you want to use V-Ray for this. It's just basically once we mesh it, it's going to be a mesh, so you can use it in V-Ray or you can use it in my Arnold. I'm going to show you how to use it in my Arnold, and you guys can choose whichever one render engine you want to use, and you're all probably going yay, and that's fine with me. Whatever you want to use, as long as the outcome, the result, the final result looks good, I'm okay. All right. I'll see you guys in the next video.